In this module of the Step 7 Odyssey video, we're going to continue with simulation and do some I/O structure work with some more data blocks. In the last module, we left off with writing the first rung of the auto sequence, and we also created a data block called SimIO. I have modified that data block after testing it a little bit, and what I did here is instead of making an array of bytes, I made an array of a UDT. So we haven't talked about UDTs in this video, but a UDT is a data structure such as this. This is an array of bools. It's actually not an array, it's just individual bools named 0, 1, 2, 3, 4, 5, 6, 7 as such. And so rather than being an array of bytes, these inputs are an array of the UDT UIO byte. The reason that I did this is because if you type in the direct address of one of these IO points, so I'm going to do that here just as a test, the address would look like this. So if I typed it in directly, db10.dbx, and we'll use 0.3, and that's the direct address. So that direct address would have just appeared without any symbols attached to it because I made an array of bytes. Unless you actually use the byte as the address, you would not get a description like this. So what I get here is I get the name of the data block, SimIO, then I get the element number input 0, and I get the _3 that was part of the UDT. So this is useful from a descriptive standpoint. We can still put a description here if we want to. We are also going to create another data block that is going to be the status of our inputs. This is actually a common thing to do whether you use simulated inputs or real inputs. So let's go ahead and do that right now. We'll use DB11 since we've already used DB10. We're going to use the lower data blocks for other things. And I am going to call this input status. And what that does is if I use a direct address here, then it will say in status 0.0 and it will connect directly to the IO point. So that's the reason that I'm doing it in this structure. So we'll go ahead and open the data block now and create it. I'm going to show you where I'm getting some of these IO points from. I actually did create another spreadsheet. It's actually the same spreadsheet we used in the last video. See all the symbols that we re-imported. As I said, these spreadsheets tend to kind of grow organically, but they're a good place to keep things. So just like I have an address here of db10 dbx 0.0, right, the simulated direct address, and then this is the symbol that comes from it. I'm going to get to do the same thing with my status. So it will say in status, inputs, 0, that sort of thing. Let me go ahead and drag this up and get it out of the way, and then we will create our data block. So I think we're going to create probably about 20 bytes worth of data here, and since we called it in status, I'm just going to call it input and we will make it an array from 1, actually from 0 to 19, that's 20 bytes. And we can individually comment these. That's another good thing about using this method. And we're going to use the same UDT that I created before. So this is what it'll look like. I'm going to go ahead and save this, and we'll take a quick view at the data, and it will look like this. So I've got input 0, 0, input 1, 0, etc. So if I were to use one of these status bits, DB11, it would look just like the other point looked. So this will allow us to create an input structure. I'm going to show you an idea that I had recently with how to use both simulated I/O and real I/O. So we're going to start at input 04, which is our first available input, and I'm getting that from, once again, here. I go to my symbols. You can see the symbols that I've already used. There's 00 through 03, so 04 is my first available input, and we will label these as we go along. And what I'm going to do here is build a proximity switch structure for inputs, and then I'm going to use the status bit, which was DB11. Now notice that I used the direct address here that corresponds with this input. And this is input status input 04, just like this input 04. The idea that I had as far as using these simulations is to create a bit, and we're just going to use one of our throwaway bits here. Let's see if this is available. Nope, not available. We'll use one of the M14 bits that we used before. M14.1. That looks available. And this is using real I/O. And so what we're going to do here is, if we want to use simulated I/O, we're going to address the simulated rung. And if we want to use real I/O, we're going to address the real rung. So actually, I'm going to move this down to the next branch, but it's going to look like this. And we're going to change this to a normally closed. Unfortunately, there is no way to drag things as you do in Allen Bradley. So we're going to name this Use Simulation, or Sim Active. So if the simulation is active, we're going to use a different set of bits, and if it's not active, we're going to use these bits. So you see how this logic works here. If active, we use this branch. If not active, we use this branch. And this allows us to switch over easily in our simulations. Now I'm going to go offline as far as this video is concerned and put some titles in here. We're going to create this pick and place, so I need to create about 8 sensors here. And I've already created all the structure for this in the simulations and the status bits, and then we're going to use the status bits in the simulation in the sequences, right? And this is typically done in real machinery. This is called input conditioning, and the general idea is, if you are extending a cylinder, you want to make sure that the extended cylinder is made, the retracted cylinder is not made, and it's called back checking. So to do this properly, I really need to name all of these things, and we're probably going to end the video about here for input conditioning, and I'm going to type all these symbols and things in ahead of time so that in the next video all this will be done. I'm going to do the same thing for the output structures, and then we're going to go into the auto sequence and program all of these inputs and outputs in this way. That will end this video. Thank you.